Okay, let's unpack this. It is Monday, February 9th, 2026. And, usually when we do a deep dive, we're pulling from these massive, noisy platforms.
Viral threads, big news sites, yeah.
It's the stuff that's screaming for attention. But today,
Mm.
I think we're going completely off-road.
We really are. It's almost like we're time traveling back to a quieter internet. We've stumbled into the world of the personal blog.
And not just any blog. We're looking at a site called qianmeng.org.
Mm.
It's all text, no pop-ups, no algorithm trying to sell you shoes, just a chronological archive of one man's life.
And the author, he goes by Ang, and he calls him, I love this, an old software plumber.
A software plumber. It's such a great title, isn't it?
It's so specific. It implies he's not interested in the flashy stuff, the UI, the marketing. A plumber cares about the pipes.
Exactly. Flow, pressure, leaks, keeping the system running.
And that's what we found. He applies this plumber mindset to absolutely everything, not just code.
He applies it to his garden, his health, and what we're talking about today, his fish tank.
Right. The specific source we're diving into is a post from just this afternoon. It's titled, Notes on Fishkeeping, Part 192, Unlocking the Growth Potential of Polar Parrot Cichlids.
Part 192. I mean, just let that number sink in. This is not some top 10 fish tips article written for clicks.
No, this is entry 192 in what's clearly a decade-long logbook. A massive archive.
So our mission today is kind of twofold. First, we're going to get into the actual biological mystery he's trying to solve, why his fish aren't growing.
Which is surprisingly high stakes if you're an aquarist. But second, and I think this is where it gets really interesting for everyone, we're going to look at the mindset. We're going to see how an engineering mind debugs a biological problem.
Because whether you care about fish or not, the way this guy approaches the problem is just a masterclass in troubleshooting. He's not guessing.
He's debugging a living system.
Exactly. So by the end of this, you're going to understand the invisible chemical factors that can stunt growth, literally and metaphorically. And you're going to see the value of what I'm starting to call radical documentation.
Oh, I love that. Radical documentation. That fits perfectly.
So let's get into the tank. Let's set the scene. Ang has a problem with a specific type of fish.
The Polar Parrot Cichlid. For anyone who hasn't seen one, they're a hybrid species. Small, kind of round, cute, with a beak like a parrot.
And they're supposed to be pretty robust, right?
Very robust, which is why they're so popular. And by most metrics, Ang's fish are doing great. He says he has several pairs. They're healthy, active, eating well.
And this is the key part. They're sexually mature.
He explicitly says they're producing spawns. They're having babies.
Now, to me, that sounds like case closed. If an animal is healthy enough to reproduce, you'd think the environment is perfect. Biology usually shuts that down first if things are wrong.
That's the general rule, yeah. Energy's expensive. You don't waste it making babies if you're stressed or starving. So the fact that they're breeding means they're comfortable.
But comfortable doesn't mean optimal. And that's the glitch here. Despite being adults, despite having families, they're tiny.
He calls them stunted. And the funny thing is, he didn't even realize it at first. It's that danger of an isolated system.
Right. If you only ever look at your own tank, then normal is just whatever you see every day. You have no benchmark.
Until he took a field trip, he writes about going to a local fish store.
The classic, wait a minute moment.
Totally. He walks in, sees the same species in their tanks, and they're just beasts compared to his.
He even put photos in the post. The difference is huge.
Significantly larger. So being the engineer he is, he goes home and pulls the data sheets. He looks up the documentation for the hardware.
And what do the specs say?
A Polar Parrot Cichlid can, or should, reach a size somewhere between 7 and 13 centimeters.
13 centimeters. That's a decent-sized fish. That's like a big smartphone.
It's a substantial fish, yeah. And his were nowhere near that ceiling. They were hitting a metaphorical and literal glass ceiling.
So that's the central question he's asking. Can my current fish ever reach that potential? Or is it too late? Have they just missed their growth window?
And this is where that software plumber brain really kicks in. If this was slow code, you wouldn't just stare at it. You'd look for the bottleneck. You'd check the variables.
And that's what he does. He starts referencing past experience with other species he's kept, jewel cichlids and zebra cichlids.
He's looking for patterns in his own database, right? He knows from those past deployments that if they're breeding, the genetics are probably fine, the hardware is good.
So the problem has to be the environment.
It has to be. He identifies 3 key variables. The first one is space.
Variable A, the container size.
He finds that for these fish to get into that 7 to 13 centimeter range, the tank should really be over 75 liters.
Okay, so if his is smaller, they might just feel constrained.
Exactly. It's about volume, but it's also about bioload. Smaller water volume concentrates everything. It's like trying to run a high-performance app on a server with no RAM. Space equals potential.
Makes sense. Okay, variable B, the inputs, diet.
And here he critiques himself. He admits he's been relying mostly on flake food.
Which is what most people do, right?
It is. But if you want mass gain, it's like trying to build muscle on potato chips. He identifies a need for a protein-rich diet pellets, live food, to unlock that next level of growth.
Inputs equal outputs. But this is where it gets really interesting for me. Variable C, the invisible one.
The nitrates.
Right. Most people, myself included, think you'd change aquarium water just to keep it looking clean. But Ang gets into the specific mechanism.
This is the crucial scientific detail. He says nitrate buildup inhibits growth hormones.
Let's unpack that. It's not just that the water is dirty, it's that the waste is creating a chemical signal, telling the fish's body to stop growing.
That's it, effectively. From an evolutionary standpoint, it makes sense. If you're a fish in a small, drying puddle, waste concentration goes way up. If you keep growing bigger, you'll run out of oxygen and die.
So the body has a built-in off switch. High waste means do not grow.
It's a survival mechanism. But in a glass box, that signal just accumulates. And Ang realizes his water changes were maybe enough to keep them alive and breeding, but not enough to flesh out that hormonal suppressor.
Wow. So cleaning the tank isn't just cleaning, it's hormone management.
That is a perfect way to put it. You're flushing the inhibitor so the growth hormones can actually do their job again.
So he has his hypothesis, space, protein, low nitrates. Now, being who he is, he doesn't just, do it and hope. He sets up an experiment.
Of course he does. The A/B test, pure engineering.
He says for the coming months, he's splitting the stock into two distinct environments.
Environment 1, a standard aquarium. Glass probably looks nice, the legacy system.
And environment 2, an EPA box.
I love that he calls it that.
Okay, for anyone listening who isn't a fish breeder, what is an EPA box?
He doesn't give the exact specs, but it's basically one of those heavy-duty gray or blue industrial plastic tubs. A storage tote. They're stackable, utilitarian, opaque.
So he's taking these beautiful tropical fish and putting them in a gray plastic tub.
Because the tub likely has more water volume and a bigger footprint, he's stripping away all the aesthetics to optimize for the variables.
It's function over form in its purest state.
Completely. He's asking, if I give them an ugly, massive home with clean water, will they turn into monsters?
And he says he expects results in the coming months. Which brings us to the second part of this whole thing. The fact that we know he will follow up.
Yes. He's not going to forget about it.
Because, like we said, this is part 192 of his Fishkeeping notes. But if you zoom out on the blog, my God, part 192 is nothing.
This is where the context of the source just becomes incredible. It's not a blog, it's a documented life.
Look at the numbers. It's February 9th, 2026. He's already published 27 posts this month.
That's almost 3 a day. The velocity is insane.
And the categories. We've got notes on fish keeping, we've got notes on Elixir Erlang programming, notes on Python, notes on AI.
Notes on Haskell programming. He just published part 53 of that one.
But it's not just tech. There's notes on dieting, notes on meditation, notes on guitar, notes on home improvement.
And the big one, notes on gardening. Do you see that number?
I do. Part 802.
802. Posts about gardening.
It's staggering.
It speaks to a very specific personality, the tinkerer, the polymath. He doesn't just do things, he studies them and documents the process. Compiling code in Rust or composting in the garden, the method is the same. Observe, hypothesize, test, document.
And the archive goes back to 2011. There's a consistency here that's just, you never see this anymore. The sidebar shows 62 posts in January, 62 in December. It's a machine.
It's discipline, but I think it's also about his values. Did you see the do support section in the footer?
I did. It's a very specific list of organizations.
The Electronic Frontier Foundation, the EFF, the Free Software Foundation, FSF, the Tor Project, Wikipedia.
That paints a very clear picture of his worldview, doesn't it?
It really does. These are all organizations dedicated to a free and open web, to open source software. He's a believer in floss-free, Libre, and open source software. He believes knowledge should be shared.
And that's a great connection. In a way, he's treating his fish tank like an open source project.
100%.
He's not hiding his failures. He's saying, look, my fish are stunted. Here's the bug report. Here's my proposed patch. I'm going to test it, and I'm publishing the results for everyone.
Precisely. Social media is all about posting the success, right? The prize-winning fish, the perfect tomato. Aang posts the bugs, he posts the struggle. That is the open source ethos applied to life.
It's a kind of vulnerability that doesn't feel vulnerable. It feels scientific.
It's the software plumber moniker. If a pipe is leaking, you don't pretend it isn't. You find it, you document it, you fix it. It doesn't matter if that pipe is carrying data packets or aquarium water.
And just to give everyone a sense of this guy's week, look what else he's posted in February.
It's such an eclectic mix.
Okay, so around the same time he's writing about stunted fish, he's writing notes on Haskell programming, part 53, generating documentation.
So he's writing documentation about generating documentation. That's very meta.
Then there's notes on gardening, part 802, why the red pineapple.
Pure curiosity. He's debugging the garden. Why did this one plant do this one thing?
And then notes on photography, part 228, lessons in urban photography.
So he's moving from deep technical abstraction in Haskell to biological observation in the garden to artistic composition in the city, and then back to water chemistry in a fish tank.
It really challenges that idea that we have to be just one thing. You know, you're a coder or you're a gardener. Aang is just a learner.
He's a tinkerer with a capital T. And look at the language in the fish post. Unlocking growth potential, variables, inhibitors. He sees the world as a series of interconnected systems that you can optimize if you just pay enough attention.
So that EPA box experiment, if he treats the tank like a server, then moving him to the box is just upgrading the hardware.
Or migrating to a bigger cloud instance,
Yeah.
And the water changes. That's garbage collection. It's clearing the cache so the whole system doesn't lag.
I love that. Cleaning the fish tank is just clearing the cache.
It really is. If you don't clear the cache, the nitrates, the system slows to a crawl. The growth hormones stop firing. The process hangs.
So what's the biggest thing that stands out to you here? Is it the fish science or the guy behind the science?
I think for me, it's the intersection. We tend to compartmentalize, We have our analytical work mode and then our hobby mode where we just wing it. Aang applies the rigor of his work, that software plumber rigor, to his hobbies.
And that's why he spots things like the nitrate hormone.
Just like he'd read the documentation for the Erlang programming language.
That's a powerful idea. We could all probably stand to treat our lives a bit more like a project that needs debugging.
Absolutely. If something isn't working, if you feel like you aren't growing in some area, maybe don't just blame yourself. Look at the variables. Is the tank big enough? Is the diet right? Is there some invisible waste building up in the environment?
Okay, so let's recap the plan for the fish.
The plan is bigger tank, over 75 liters, better inputs, so a high-protein diet, and most importantly, manage the environment by keeping nitrates low to unlock that hormonal potential.
And we're all waiting for the results of the aquarium versus EPA box showdown.
I am genuinely invested now. I really want to know if the industrial box wins.
Me too. It's a real cliffhanger.
It is.
You know, it makes me think. We talked about how the nitrates are invisible. You can't see them, but they're stopping growth.
A silent stressor, yeah.
So what are the nitrates in our own environments, in our offices, our homes? What are the invisible things that accumulate that we stop noticing, but that are secretly signaling us to stay small?
That is the question, isn't it? Maybe it's clutter, maybe it's constant noise, or just a lack of real downtime. Just like the fish need clean water to sense that it's safe to grow, maybe we need clean time and space to do the same thing.
And I've one last thought for you, listener. The EPA box.
The ugly plastic tub.
Aang is testing if the ugly functional box works better than the pretty glass tank. It's function versus form. If those fish grow bigger in the plastic box, what does that say about where we prioritize aesthetics over utility? Are we keeping ourselves in small, pretty glass tanks because they look nice, when maybe we should be in a big, ugly bucket where we could actually grow?
That is a provocative thought. Are you optimizing for the display, or are you optimizing for the organism?
Exactly. Something to think about while you check your own water parameters today.
Indeed. Keep your nitrates low.
Thanks for listening to this deep dive into the world of the software plumber. We'll catch you on the next one.